looking at the sky. Such a simple gesture, isn't it? We lift our heads, glance at the stars, and continue with our lives. Yet some of the greatest turning points in human history began with that exact motion, the simple act of looking up. Think about it. For millions of years, humans were tied to the ground. We hunted, we hid from the elements, we searched for shelter. Survival came first. But even then, humans stopped at night and gazed at the sky. Why? Because something was up there, something they couldn't name but could feel. Curiosity. To ancient civilizations, the night sky was a canvas of mysteries. Those shimmering dots, were they gods? Were they signs of fate? Were they markers of time, used to guide harvests? They had no idea what they were actually looking at. Not until the invention of the telescope. When Galileo pointed his telescope to the heavens, everything changed. He saw mountains and craters on the moon. He discovered moons orbiting Jupiter. Suddenly, the heavens were not perfect, divine spheres, they were physical worlds. And humanity realized something profound. The sky was far more complex than we ever imagined. Centuries passed. Telescopes grew larger. Mirrors became more precise. Computers entered the scene. And the stars we once saw as dots of light became identifiable objects, each with planets of its own. And among those planets, some looked strangely familiar. Some looked like Earth. This realization rekindled one of the deepest questions humanity has ever asked. Are we alone in the universe? This question is not just scientific. It's existential. Who are we? Where did we come from? Is life a cosmic rarity or a universal rule? For the first time in all of human history, we are close to an answer. We don't just look at the stars anymore. We decode their light. We measure their shadows. We analyze the molecules in alien atmospheres. We can determine whether a distant world has water, suitable temperatures, or chemical traces that can only come from life. All of this serves a single purpose: to find the signature of life. Maybe microbial, maybe hidden beneath oceans on a distant world, maybe breathing under a thin, fragile atmosphere. Or perhaps intelligent, aware, watching, wondering, just as we do. And so this documentary begins with that first glance, that moment humanity looked upward, the moment our eternal curiosity was born. Have you ever truly thought about how big the universe is? Not just very big, but big enough to shatter the limits of human imagination. On Earth, everything feels enormous to us. Continents, oceans, mountains, to our senses, they seem massive, but when we try to understand the scale of the universe, we suddenly realize something shocking. Earth doesn't even qualify as a single grain of sand in a vast desert. Imagine gathering all the sand from every beach on our planet. Billions, trillions of tiny grains. Now imagine that even this is not enough to match the number of stars in the universe, and most of those stars have planets orbiting them. Our solar system was never special. Learning this was one of humanity's greatest milestones. When we try to measure the universe, we're forced to use the concept of light years. 1 light year, the distance light travels in a single year, is about 9 trillion kilometers. But the human mind isn't built for numbers like trillion. We can write it, we can calculate it, but we can't feel it. Light takes about 8 minutes to travel from the sun to Earth. That's our local neighborhood. But the next nearest star? Proxima Centauri. Distance, 4.2 light years. If we tried to go there with today's spacecraft technology, it would take around 80,000 years. That's longer than human civilization has existed. And then there's the Milky Way, a galaxy of 100 to 400 billion stars. Even at the speed of light, it would take hundreds of thousands of years to cross it. And the Milky Way is just one of 2 trillion galaxies in the observable universe. 2 trillion. This is the point where we must accept a hard truth. We can calculate the size of the universe, but our brains cannot truly comprehend it. At such a scale, the idea that life appeared only on this tiny planet seems almost absurd, mathematically speaking. With this many stars, planets, and galaxies, life occurring in only one place is wildly improbable. This doesn't mean life is everywhere. Maybe it's rare, maybe it needs perfect conditions, maybe it hasn't had enough time to evolve elsewhere, but the vastness of the universe tells us one thing. If the universe is an ocean, we are merely a drop of water standing at the shore, and we haven't even begun to explore the waves. This chapter exists for one reason. Without understanding the scale of the universe, nothing else in this documentary makes sense. Because to understand the search for life, why it's so difficult, so meaningful, and so uncertain, we must first understand just how massive the universe truly is. When we point a telescope at the night sky, we only see a tiny fraction of the universe. The rest is darkness. But this darkness does not mean emptiness. In fact, the greatest mysteries of the cosmos hide precisely in the parts we cannot see. For decades, scientists tried to understand the structure of the universe. Why do galaxies cluster together? Why do some race away from each other? How do stars remain bound in such perfect formations? While searching for answers, they stumbled upon something staggering. All the matter we see, stars, planets, nebulae, makes up only 5% of the universe. The remaining 95% consists of two invisible giants, dark matter and dark energy. Dark matter doesn't interact with light, which makes it invisible. It acts like a hidden skeleton, holding galaxies together, a cosmic glue. Without dark matter, galaxies would have torn themselves apart long ago. But the stranger component is dark energy. Instead of slowing the universe down, dark energy is accelerating its expansion. This discovery shattered everything we thought we knew about physics. The universe isn't just expanding, it's speeding up. Do you know what that means? Distant galaxies are moving away faster every second. A day will come when many of the galaxies we see today will vanish from view. Not because they disappear, but because their light can no longer reach us. This unseen portion of the cosmos is actually the largest part of the story. Yet we cannot observe it directly. We only see the effects it leaves behind. Imagine solving a puzzle with most of the pieces missing. You can guess the picture, but you can't see the whole thing. Still, you know the missing pieces matter. Without them, the image is incomplete. Humanity is in that exact position. We are progressing, learning, discovering, but most of the puzzle is still invisible, and that invisibility pushes us to go deeper, to question more, to search further, because maybe, just maybe, the answers that define our origin, our place, and our future lie hidden in that vast cosmic darkness. When we look at the night sky, we see stars shimmering, but that flickering light is far more than a simple glow. Light is a message, a letter written by a star and sent across the cosmos, and humanity is only now learning how to read it. When scientists first proposed the idea of analyzing light by separating its wavelengths, many dismissed it. What could light possibly tell us, they wondered. But that question was exactly where they were wrong. Inside a star's light are chemical fingerprints, hydrogen, helium, heavier elements. Each one leaves a unique mark, a spectral signature, just like a human fingerprint. And here's the astonishing part. If a planet orbits that star and it passes in front of it, the planet absorbs a tiny fraction of the starlight. This creates a small dip, a thin notch in the star's spectrum. Scientists study that notch. They break it down, analyze its wavelength patterns, and from that alone, they can identify what gases exist in the planet's atmosphere. This was a turning point for humanity, because knowing a planet's atmosphere is the most crucial step in figuring out whether it could host life. Oxygen, ozone, methane. If several of these appear together, it usually suggests biological activity. In other words, life may be present. Just imagine it for a moment. We point our instruments at a place we cannot see with our own eyes, a world millions of kilometers away. And within the faint trembling of its light, we hear a whisper. There may be life here. Light was never just something we saw. It was a messenger. carrying the secrets of the universe. Galaxies are among the most astonishing structures in the universe, but they are not frozen, motionless systems as many imagine. On the contrary, galaxies are dynamic, evolving, colliding megacities of stars. Each galaxy contains billions of suns, stars like ours, some far larger, some smaller, and some unimaginably strange. But what makes galaxies truly remarkable is that none of these stars exist alone. They are all part of a vast gravitational design. When you picture a galaxy, you might imagine a clean spiral disk, but that image is just a snapshot. In reality, galaxies are alive. They twist, stretch, tremble, and follow complex gravitational rhythms. At the heart of a spiral galaxy lies a supermassive black hole. Its gravity is so immense that it can swallow stars, gas, and dust effortlessly. Yet it also regulates the motion of everything around it. The galaxy rotates in harmony with this invisible conductor. And here's something even more intriguing. Galaxies are never truly alone. Most exist in gravitational relationships with others, pulling, pushing, swirling around one another. Sometimes these interactions escalate into a colossal, cosmic collision. Two galaxies slowly drift together over millions of years. Their stars rarely collide, because the space between them is unimaginably vast. But the galaxies themselves deform, stretch, and twist, like fabric pulled from opposite sides. These cosmic collisions are the universe's greatest architectural events. Galaxies merge, reshape, and ignite waves of new star formation. The universe reorganizes itself, turning chaos into structure. Even the death of a galaxy isn't destruction, it's transformation. Matter rearranges. New stars are born, new planets emerge, new chances for life appear. And this dance will continue for as long as the universe exists. An endless cycle of beginnings and endings, all moving to the silent music of gravity. Even our own Milky Way is part of this vast choreography. We are slowly drifting toward the Andromeda Galaxy. In about 4 billion years, the two will collide. Not as a catastrophe, but as the birth of a new galaxy. The universe is not a static void. It is a creative machine, constantly reshaping itself. From our tiny world, the sky may seem calm, but above us, the greatest cosmic dance is always unfolding. Deep within the universe, stars are born, they live, and eventually they die. Their lives are nothing like human lives. A star's existence stretches across millions, sometimes billions, of years, and each phase of that existence shapes the cosmos. It all begins with a cloud of gas, a massive cosmic mist made of hydrogen and helium. But within this mist, small regions start to collapse under their own gravity. They contract, heat up, contract more, heat up even more, until one moment, when nuclear fusion ignites at the core. That moment is the birth of a star, a light switch turning on in the darkness. A new sun begins to burn. Young stars shine fiercely. They fuse hydrogen atoms into helium, releasing tremendous amounts of energy. This energy becomes light, heat, and radiation, the lifeblood that shapes the planets and dust around them. Without stars, evren tamamen ölü bir yer olurdu. Çünkü yıldızlar yaşamın motorudur. But nothing lasts forever. The larger a star is, the faster it burns through its fuel. Giant stars live fast and die young. Smaller stars burn slowly and live longer. Our sun is middle-aged, about 4.6 billion years old. As fuel runs out, the star becomes unstable. Fusion slows. Outer layers expand dramatically. The star swells into a red giant, growing hundreds of millions of kilometers in size. One day, our sun will also become a red giant. It may expand all the way to Earth's orbit. Whether the Earth survives or not is uncertain, but the fate of the sun is clear. Every star must die. The death of massive stars is far more dramatic. When their fuel is finally exhausted, the core collapses. In a split moment, the energy balance shatters, and the star explodes in a supernova. A supernova is so powerful, it can outshine an entire galaxy. But here is the extraordinary part. Supernova explosions create the elements of life. Iron, carbon, oxygen, gold. Everything that makes up our bodies and our world comes from those explosions. We are, quite literally, made of stardust. The death of a star is not destruction, it is renewal. The gas and dust left behind become the raw material for new stars and new planets. The universe recycles itself endlessly. Every death seeds another beginning, so the story of stars is not just about distant lights in the sky. It is about us, where we came from, why we exist, and what we will someday return to. We are children of stars. Every time we look up at the night sky, we see our own origins shining back at us. The black hole is no longer just a distant threat in the sky. Even if we can no longer see it, we feel its presence every second. Reality itself, yes, reality, is no longer stable. The fabric of spacetime stretches, twists, and begins to tear, and this collapse becomes most visible on Earth's surface. Ocean levels behave in ways no tide chart can explain. On one coast, the sea pulls back for kilometers, while on the other side of the world, it rises like a monstrous wall. The upper layers of the atmosphere tear apart, making the sky ripple like fabric, as if an invisible giant were squeezing the planet in its hands. Even shadows have stopped acting normally. Sunlight bends under the black hole's gravity. Shadows stretch, twist, and even flow in impossible directions. Even children ask, "Mom, why does my shadow look broken?" Scientists finally agree on one conclusion. Earth has entered an irreversible drift toward the black hole's event horizon. Like a leaf falling into a whirlpool. Once you're caught, you cannot escape. You can only be pulled inward. Now there is a strange silence in the cities. Cars still move, people still walk, but everyone shares the same question. Is this only the beginning? No, this is merely the first crack in a dying reality. And the cracks are widening fast.